In this video, we're going to be talking about the anatomy of a battery. So a battery is just a small storage tank which allows it to store chemical energy, and through that chemical energy, it performs chemical reactions which then extracts electrons into a separator. From this separator, it sends those electrons from the negative terminal to the positive terminal. The flow of these electrons to get from one side of the battery to the other through a conductive wire is called electricity. Now we're going to be looking in depth on how all of this is created, how these electrons move from the negative terminal to the positive terminal. So in the battery, we have special elements and compounds that allow the chemical reactions to occur. So these special elements and compounds are located in the anode and the cathode. In the anode, we have zinc hydroxide, and with zinc and hydroxide, they come together to be able to create zinc hydroxide. Now the thing about this is that it releases electrons as well as it releases water during this chemical reaction. So we experience something called oxidation in the anode, where the hydroxide ions with zinc come to create zinc hydroxide, releasing water and electrons. And next, we move to the cathode. In the cathode, there's manganese oxide. So this manganese oxide reacts with the water that was released from over here in the anode, as well as the electrons, as well as one free electron that comes from the electrolyte over here, this light green part. So with the manganese oxide along with the water and the free electron, they come together to create a different form of manganese oxide. And while doing this, they release hydroxide ions, which these hydroxide ions then come together to be able to go with the zinc in the anode over here. So this creates a loop or systematic loop of a continuation of these chemical reactions. And one thing that we notice is that it's releasing electrons over here. Meanwhile, over here, it's taking in only a few of the electrons. So if there were 4 electrons being released over here, only 1 would be taken in for this process, the reduction process. So in other words, we're having a total of 3 electrons entering into a part of a battery called the separator. Now the separator is where these electrons get stored in after the chemical reaction. Now the thing about the separator is that it doesn't connect the negative terminal to the positive terminal. The electrons meet up over here at the negative terminal since they're negatively charged. And the thing is, they want to get to this positive terminal. So they repel each other. But since the separator doesn't connect the negative to the positive terminal, there's a lot of unbalance over here happening in the separator. So what happens is we need a conductive material such as a wire that connects the negative terminal to the positive terminal. Now, if we have something in the middle, and now with this wire being created, the electrons are easily able to flow from the negative terminal to the positive terminal. This flow of electrons is what we call as electricity. Now, if we were to have something in the middle, such as a light bulb right between, like if this wire was running and in between that wire there was a light bulb connected to these conductive wire, then what happens is the electrons will have no choice but to move through that light bulb, hence creating work for us and illuminating light. There are also different types of batteries, and their purposes vary from reason to reason. However, 2 main types of batteries that we have are unrechargeable batteries and rechargeable batteries. Unrechargeable batteries is where there are no longer any chemical reactions happening inside the cathode and the anode. And because there's no longer any type of chemical reactions, electrons are no longer going to be released from these compounds. And because of that, and because they're not going to be released, there's no flow of electricity, hence the battery dies. Now this is classified as an unrechargeable battery. And some are located over here. These are unrechargeable batteries, and once they no longer have these chemical reactions occurring in them, we just toss it in the recycling bin since they have no purpose. However, we have these rechargeable batteries. So what happens is when we use the battery, the chemical reactions still occur inside, but what happens is we're able to plug it into a power outlet or a source where we're able to get electricity from. There, the electricity basically undoes everything that happens. They push the electrons that are in the separator back out, and they also make sure that any kind of hydroxide ions that are not where they're supposed to be, they also move them back and prepare it for the next prepare it for like use later on. Also, the electricity sends in electrons. So even if there isn't some chemical reaction happening, like even if it sometimes doesn't work, the electrons, since there's an excess amount of electrons still being present inside because of the charging, it'll still be able to send it to the separator and allow the battery to continue to work until it's no longer rechargeable. Now, the series of chemical reactions that happen between the anode, cathode, and electrolyte are called electrochemical reactions. Through these chemical reactions, they produce electricity through the flow of electrons, but they also have these chemical compounds that release these electrons through the process of oxidation and reduction. So now let's see the battery actually work in action. So you have the cathode over here, or the positive terminal, and the anode over here, or the negative terminal. So we have these two wires, these copper wires. So it's a conductive wire that allows these electrons to pass through. So if we were to have this light bulb over here, the electrons over here, they're going to pass through and they want to get to this positive terminal. And if we connect it like this, we don't see anything, but the electrons are still passing through. But if we were to have a load in the middle, we would actually be able to see it like this. The electrons have no choice but to pass through the light bulb because the electrons have to get to the positive terminal. So they will actually do work for us, illuminating this light bulb. All right. Another way we can figure out that the electrons are moving is through a multimeter. So we're going to on this. So since this is a DC, the battery uses a DC current, we're going to put it at 20 over here. And we're just going to check the voltage. You can see over here, it's somewhere around 1.5, or to be exact, 1.46, 1.47, but it could be rounded to 1.5 volts, as it's shown over here on the battery. So, in conclusion, a battery has 4 different parts. We have the electrolyte, anode, cathode, and the separator. The electrochemical reactions that happen inside of the battery release these electrons, which enter into the separator. However, the separator doesn't connect the negative terminal to the positive terminal, so the electrons want to get to this positive terminal, and the only way they can do that is through a wire which connects both parts over here, a conductive wire. So when we looked at this example over here, the electrons are passing through, we just can't see it, but if we were to have a load in the middle, it would prove that the electrons are passing through.